The first one is to make sure that MVRF is not noisy. So this is one signal that you want to pay attention to. Keep it away from all the other signals, and make sure that you provide enough trace width so there's no current starvation. Although these are very low current consuming signals, you just want to keep it away from other signals so there's no additional noise coupled on them. When you're measuring the VREF, make sure that you measure it at the decoupling cap for the VREF. Measuring the VREF at any other point would not show you a valid information. The other information here again on VREF, as you can see, the trace that is highlighted as red line or red signal in this board layout, it is away from all the rest of the signals. It is definitely selected to be wider or have a wider width than the rest of the signal. And make sure that you provide the capacitance that is required. Another feature, as you can see, we're discussing VREF in detail in different aspects, and the emphasis is that this one signal is the deciding factor for all the SDRAM and in our controller. And so it is very important to be paying extra attention to this one signal. So here we're discussing that do not use a current a VRF DC-DC generator that does not provide enough current. We do have spec in our hardware spec that specifies the amount of current that is required for VREF for each device. So make sure that has been observed. The other pitfall would be that make sure to avoid cross-plane splits, and make sure you avoid trace over and reduce the if you avoid switching, or if you have to make sure they're not over each signals from the different levels. The other aspects that you need to pay attention to are the spacing between each of the byte lanes, and following the rule of trying to make sure that say if you need to if you're using DDR2 and you need to trace match the length between the traces, then you follow each byte lane separately and start with the farthest byte lane, then work your way to the closest byte lane, and make sure 10 mils is spacing is observed between the byte lanes, and there's a half an inch spacing that is or the skew between all the byte lanes does not go beyond half an inch. Do not forget your terminations. Here you see the terminations that is for DDR3 specifically. That is, we've noticed that people might miss or try to configure them similar to DDR2, and that is not correct. So pay attention to the termination required for DDR3 once they get to if you're laying out the parts on your board and you're not using a DIMM. The other important feature, again, this is to re-emphasize what was discussed previously, that if you do have, for DDRs, there's a selection between DDR types. That is a pin that needs to be configured on the board. during power on, when the board is being powered on. So make sure that that pin has been brought up and proper pull up and pull down is applied. If you're building a board and you are considering an option to keep it for a while and expand the memory size, make sure you leave options open for yourself and leave the footprint available so you can use to expand it by using soldering different DRAMs at a later time. Only use the topologies that are approved by JEDEC. There are many ways that you can route your system or DDR subsystem, but please do follow the JEDEC approved topologies. Do not separate your power planes. DDR does provide two different power planes, it calls them VDD and VDDQ, but we do not want to separate these two, and we use a single power plane. When you're using your calculations or timing budget, do include the slew D rating for setup and hold depending on the slew rate of the device that you're using. Also, an important information to note that if you're soldering your DRAMs on the board and you're doing your own layout, make sure you bring out, because all the DDR2 and DDR3 parts are BGA and there's not going to be any access to reading the signals when you want to troubleshoot. So there are predetermined ways that you can bring these signals out, and JEDEC approved ways that you can bring these signals out. And so if you are going to debug and you're considering you like to monitor these signals, make sure you bring the signals out. This concludes my presentation. The important information or very important references are listed here on this page for further studies. I do highly recommend that if you're using DDR3 for layout design consideration, consider the application note 3940 and to provide you with a guideline to how to set your register settings for DDR3, use the application note 4039. Thank you very much.